The year was 2047. Humanity had reached a tipping point. National tensions, economic collapse, and decades of simmering conflict culminated in the largest war the species had ever seen, World War III. Unlike the wars of old, this one escalated almost immediately to the use of fission and fusion bombs. Within months, 1.4 billion lives were lost. Cities were reduced to ash. Nations, entire governments, vanished. The very map of Earth changed. By June 9, 2050, the war ended, but the planet was scarred. Entire regions were uninhabitable, and the survivors faced the monumental task of rebuilding civilization from the ruins. Old ideologies had failed. Humanity needed a new structure. The United Nations, once a fragile body of diplomats and bureaucrats, transformed into the Human Commonwealth, a government designed to represent all humans fairly. Its structure was deliberate, a bicameral legislature, overseen by 5 elected council members, each representing one of the major continents. These council members guided laws and policy to ensure no region, no people, would be left behind. Humans, having seen the cost of prejudice, intolerance, and hubris, adopted a guiding principle: aid those in need, protect life, and seek knowledge for the betterment of all. In 2078, humanity discovered hafnium, an element capable of absorbing radiation and converting it into energy. But without radiation to feed on, it decayed. The first use was practical: rebuilding Earth after the nuclear fallout. Massive absorbers purified millions of square kilometers, making cities and farmland safe again. Only 5 absorbers were constructed, and they became symbols of human ingenuity and resilience. Humans returned to the Moon, now called Luna, and to Mars. Lunar bases were built deep in craters to shield inhabitants from micrometeoroids and solar radiation. Hafnium absorbers protected astronauts and powered mining operations. Luna yielded iridium, essential for hafnium synthesis. Mars provided thulium. With these resources, humanity could create additional absorbers and expand safely into space. In Earth orbit, Olympus Station became humanity's first large-scale orbital hub. Initially a refueling and construction station, it expanded into a training academy and shipyard, eventually housing FA-209 fighters capable of atmospheric and space operations. Advances in Higgs field manipulation allowed gravity plating and inertial dampeners, making larger ships feasible. Hafnium absorbers protected the station from solar radiation, ensuring long-term operation. Experiments at the Richard Feynman Particle Accelerator revealed the null particle, which could traverse null space, a dimension of dark matter. Radiation in null space was lethal, but hafnium absorbers allowed safe passage. The pseudo-null drive was developed, enabling humanity to travel between star systems in a fraction of the time previously thought possible. With a null drive, humanity colonized moons, planets, and asteroids: Europa, Ganymede, Callisto, Io, Titan, Triton, Pluto, and Venus. Hundreds of orbital and ring stations were built, powered and shielded by hafnium absorbers. By 2300, humans reached Alpha Centauri, discovering the habitable world Eden Prime. Colonies were self-sufficient, and humanity became an interstellar species. Communication across interstellar distances remained a challenge. Light-speed signals were too slow. Attempts to use null space failed due to radiation interference. The solution came with quantum entanglement, rediscovered from pre-war theories. Entangled communication nodes allowed instantaneous data transfer between colonies, ships, and research stations. Humanity could coordinate across dozens of star systems, setting the stage for interaction with other intelligent species. Deep within the Pleiades star cluster, humanity's reach had extended farther than ever. Among the stars glided the HES Pathfinder, a vessel built for exploration and long-range observation. Its hull shimmered faintly, powered by the pseudo-null drive, humanity's faster-than-light technology. Embedded within the structure, hafnium absorbers silently protected the ship, neutralizing dangerous radiation as it traveled through space.
Log entry: July 13th, 2400. Pleiades cluster. Captain Iko Reinhardt. I was scanning nearby systems when the alert sounded. A vessel, unknown, alien, was under attack. Beams of radiation streaked through space toward it, deadly and precise. My instincts told me we had to act. Without hesitation, I ordered the crew to intercept. I knew the half-yum absorbers would protect us, and, indirectly, the alien vessel, the energy from the incoming radiation was absorbed instantly, converted into harmless power. I could feel the hum through the hull, a quiet reassurance that neither ship would be damaged.
The alien scout vessel struggled to evade the attackers. Its hull groaned under the assault, systems flickering in response to the sustained radiation. The Pathfinder's crew maneuvered carefully, disabling the raiders without firing destructive weapons. The half-yum absorbers absorbed every beam, protecting both ships. Within minutes, the pirate vessels were incapacitated, forced to retreat. Not a single life was lost. Humanity's intervention was precise and deliberate, demonstrating both restraint and honor.
I watched the alien crew now, wary and confused. For hours, we maintained position, keeping the attackers at bay. The alien sensors tracked us, trying to understand our intentions. Their fear gradually gave way to cautious curiosity. My linguists began analyzing the alien signals. Their language was unlike anything we'd encountered. Patterns of electromagnetic pulses, modulated in ways that almost seemed musical. It was a challenge, but we were determined to communicate.
3 days passed. Initial attempts to establish communication failed. Misunderstandings sparked tension. Lights flashed across the alien vessel as warnings. Slowly, a translation matrix emerged. Patterns became words, words became phrases, and the first understanding between species was achieved.
Then they spoke a single word, their name, Sarn Imperium. Relief and gratitude radiated from the ship. They had been attacked by pirates using radiation weapons far beyond human design. They had expected no aid, yet humanity had intervened without hesitation. In that moment, I understood the gravity of first contact. We had shown them that humans acted with honor, ethics, and restraint. We had shown them who we were.
Through careful dialogue, humanity learned that the Sarn had FTL technology distinct from the null drive, and they also possessed advanced energy shields. Humans did not have shields, but the Sarn offered the knowledge as a gesture of gratitude for saving their scout. Scientists began studying the technology, laying the groundwork for future development. The null drive and half-yum absorbers, however, remained a closely guarded secret of the Commonwealth.
As we departed the cluster, I recorded my final thoughts. Today, we made first contact, not through force, but through action guided by ethics. Humanity acted to protect life, not for advantage. We learned of new technology, met a new civilization, and reaffirmed our values. The Pleiades incident will be remembered as the moment humanity extended its hand across the stars, and the stars responded in kind.
The Pleiades incident set a precedent for humanity's conduct among the stars. They were cautious yet courageous, ethical yet effective. Half-yum absorbers had protected life. Diplomacy had begun. This was the first step in a new era, one where humans would meet the galaxy with integrity and restraint. After the initial contact with the Sarn Imperium, humanity obtained schematics and theoretical foundations for their energy shield technology. At first, the scientists of the Human Commonwealth were optimistic. Here was a technology that could protect ships from the same threats that had necessitated the half-yum absorbers in the first place. Yet, as the research continued, a problem emerged. The Sarn shields were designed to block the full spectrum of radiation present in space, including the subtle background radiation of the cosmos. For humans, this presented a paradox. Half-yum absorbers required this background radiation to remain stable. Shielding it entirely would accelerate the decay of the element, rendering humanity's most critical technology useless. Months of careful analysis, testing, and iterative design led to a breakthrough. The Commonwealth discovered a key design feature in the Sarn shields. They were not absolute. Their protective layers could be calibrated to specific thresholds of radiation. By selectively tuning the shields to focus only on incoming energy, particle, and ballistic weapons, and allowing all other cosmic radiation to pass, the hafnium absorbers could function normally. With this insight, the Commonwealth realized that human-adapted shields would be far stronger than those used by any other interstellar species. They could protect against almost all forms of attack while maintaining the unique advantages of hafnium-based systems. Following the success of the Pleiades encounter, the Commonwealth sent a diplomatic mission to the Sarn Imperium to establish formal relations. These talks were cautious but productive. Humanity shared its quantum entanglement communications technology, demonstrating instantaneous interstellar data transmission. In return, the Sarn Imperium provided humanity with the details of their FTL drive system. While impressive, it was clear that their technology was much slower than the null drive developed by the Commonwealth. More importantly, humanity recognized that in their early experiments, they had approached faster than light travel from the wrong angle entirely. The Sarn method offered a conceptual correction, but not the same operational capability as the null drive. The Sarn drive system was quickly integrated into Commonwealth ships, but not as the primary drive. On board, it was presented in a way to appear as standard FTL technology to any other species scanning Commonwealth vessels. In truth, the null drive remained hidden, disguised as secondary communication hardware, preserving humanity's true interstellar advantage. The integration of Sarn technology marked the first deliberate technological camouflage strategy for humanity. Ships now appeared comparable to other interstellar powers, without revealing the full extent of Commonwealth capabilities. Meanwhile, the refinement of shields based on hafnium absorbers created vessels that could withstand far more than any other empire's defenses, combining passive radiation protection with active threat mitigation. The diplomatic and technological exchange established a precedent for future encounters. Humanity would engage with other civilizations ethically and openly, yet retain the strategic advantage of knowledge, technology, and operational secrecy. By 2420, the Commonwealth fleet had become a model of subtle superiority, advanced, cautious, and ethical, with defensive systems unmatched anywhere in the known interstellar neighborhood, and drives that could outpace anything yet observed. After the Pleiades incident and the careful diplomatic exchange with the Sarn Imperium, the Commonwealth entered a decade of urgent, quiet work. Scientists and engineers pored over the Sarn schematics for energy shielding. Linguists continued to refine the translation matrix. Diplomatic envoys ferried knowledge both ways. Entangled communication nodes for the Commonwealth, shield theory and aesthetic FTL schematics for public integration from the Sarn. But even friendship breeds vigilance. Frontier systems reported increased pirate boldness, raiding convoys, attacking isolated outposts, probing defenses. The Commonwealth Council accepted an uncomfortable truth. The tools that protected commerce and lives, hafnium absorbers, null source logistics, had to be matched with disciplined, visible defensive power. If diplomacy should fail anywhere, the Commonwealth must be able to hold the line.